would be having some more introduction for the GTM and for the DNS, generic DNS. Probably after that, we would be starting out our lab and we will perform some of the practicals. But currently, because we need to build up some of the foundation, we are still on some of the concepts building. Okay. So let me share my screen. My screen is visible to you?
Yes.
Okay. So maybe we can start up with our today's class. And okay. This is my question. How does your DNS work? Probably if you can provide me the answer, Eunice.
Yes. So when a user send a query that will as a recursive query, then if it is there in the local DNS, it will provide in the local DNS cache with those details. If it is not there, it will do an iterative query to the other DNS.
First, it will do the recursive query with your LDNS.
Yes. And if the result is not there in the LTM, then it will do the LDNS, and then it will do the query, that iterative query to the other authoritative servers. I mean, .com, .root servers and all. And .com, .root servers and all will provide the IP address of the authoritative or non-authoritative server, DNS server. So once it received from the details of authoritative or non-authoritative DNS server, it will get those IP, and DNS will local DNS will cache it, and it will send back to the user laptop.
Perfect.
And
Thank you.
Will use that. Yeah.
Thank you. So it is a bit like boss is asking for the information, and LDNS as a good employee will collect this information maybe from the root server, maybe from the .com top level domain, second level domain, or the third level, whatever, and go to the authoritative server. From there, it will have the reply, it will cache that reply, and it will send back to the client, and client can interact with that particular application directly. So if you see, the below part is the DNS part. Okay. And this above part is not your DNS part, because now application information is already aware from this client, and this client can interact with the application directly. So it won't be an DNS traffic. It can be your HTTP, HTTPS, FTP, TFTP, whatever, some other traffic. Okay. So below is the DNS part. Now, when we are saying that this client will interact with LDNS, LDNS will go to the root server. There are mainly 13 root servers, okay, which are managed by different organizations. So there can be more also, but mainly if you will see the blogs or maybe different websites, you could find out that there are mainly 13 root servers available over the internet. So these 13 root servers will have the information of the top level domain query. And from the top level domain, it will go to some of the authoritative, or it can be a non-authoritative server. So as I described you in our previous class. Any doubt for this diagram, for this picture from anybody?
No.
Good. Now we will talk about this slide. Here we are talking about how we can deploy this. How we can deploy an F5. So F5 can have a hardware solution. Okay. You can just buy whatever hardware solutions present in the market. Probably you can go to the sheets, compare that. Okay. Which model suits you. You can have virtual edition running on some of the hypervisor. ESXi, or maybe KVM or whatever. Okay, you can have on the cloud also. So public cloud, private cloud, whatever cloud you have, probably you can build it on the cloud also. Now, when we talk about F5 DNS, what all advantages we are receiving when we use F5 DNS in our environment? So maybe one of you please confirm me, what does the first line mean?
Choose the closest response. Yeah, it will have the details of the data center that it is closest. It has some intelligence which is
Correct.
closest, which is nearby.
So this is our F5 DNS. F5 DNS, as I told you in earlier class, it is a solution of GSLB. It means it can have more than one data center. So let us say there is one data center one, there is data center two, this data center in the APAC, this data center in the EMEA. Okay. Now, if user is coming from the APAC, DNS has the intelligent solution that it will send to the APAC data center only, not to the EMEA, just to avoid the latency. Okay. But if some user is coming, which is from the Europe, so in that case, it will send to the EMEA data center. Again, low latency, right? So that is how you can have closest or best performing data center. You can choose by yourself. Okay, very major part it is. So F5 DNS
I
direct.
have a question here. This one. So the intelligence means, are we setting some intelligence that it should choose the lowest delay data center? Or what?
Yes. There are a couple of load balancing mechanism that I would be explaining you in our later on classes. Okay.
Okay.
So this is your first point. So F5 DNS direct user to the nearest data center that will provide the best application experience. And what about the second point? Abdul?
It is
Okay,
health
you
check.
continue. You continue. Yes, it is about health check. Like the health check we perform in the LTM. Same health check. So in this health check, it will monitor what? F5 DNS will monitor. Let us say there are two data center. After this data center, there is an LTM. This data center is also an LTM. Okay, there are two data centers. This is your DC1. This is your DC2. These are the VIPs of the application, and behind them maybe there are multiple of application server. Okay, there can be a number of application server. I am just using two. So there can be more than two. So what it will now try to understand what F5 LTM will do. F5 LTM will monitor these guys. Okay. In turn, F5 DNS will monitor this VIP. Are you getting this point?
Yeah, but how it is coming to the particular virtual server or pool
Don't
level?
worry.
No.
That we will discuss. Okay, I will tell you in the practical also how it is coming to the FIDNS. What are the way? What is iQuery? There are a lot of fundamentals need to talk about. Okay, but just for time being, you can just understand that FIDNS has the information of the all the VIPs, and it will closely monitor them to ensure that your distributed applications are always fast and available. Any doubt? Abdul, hand it out to you.
Good morning, sir. I just joined.
Okay, it's all right. So I'm just explaining about FIDNS
Please continue.
advantages. Okay. Now, let's come to the third point. Route traffic based on business logic to available application. What does that mean? It means that maybe we can have n number of scenarios where we want to send the traffic, let us say, to this data center, not to the data center 2. In that case also, an administrator who is managing DNS have the capability to tune the traffic as per the requirement. So it routes the traffic according to the business policies or the current network or maybe user condition. Okay. Last point, scalability. Anyone? What is scalability?
We can expand.
Right. Scalability means expansion, future planning. So hundreds of thousands to millions of DNS requests per second can be entertained by your FIDNS. Very highly scalable. Okay, I will be gonna explain about them in our further slides. See here, very important slide. If you see, this is my traditional. Traditional design. This is my model. Take a minute and explain me what all components you can see the difference over here. Then I will be gonna explain about those. No explanation, just you need to tell me what components are missing and what more components are there. Just simple.
First, the traditional design understand. The second one didn't understand. For the traditional design, we have in internet. Then the firewall, we do the netting and all. And
So
those VIP
internet
will be netted.
internet is representing clients. Okay, that clients are coming through internet. That is representing this thing. Here also internet is representing client. That clients are coming.
Still understand the first one only.
Mhm.
Traditional one. For the client will come and it will come to the firewall. It will
Mhm.
do the netting and it will do the netting for the virtual IP, and it will just, I mean, the load balancer will just do the traffic reversing.
Let
So from the internet
let
itself,
me give you one more hint. Here we are talking about DNS. DNS scalability only. So just see both of the diagram again. We are talking about DNS, nothing else.
okay. And in that DNS case, I think for the first one, for the resolving those particular IP, they should get from the internet only, internet DNS server.
Both are
Because
on-prem.
how they will, how
Both
they
are
use
on-prem.
trying
Both are on-prem.
on-prem. In that
Both are
case,
on-prem.
good.
Both are on-prem,
Okay.
but one is the traditional design, one is the modern.
Okay. Now
Excuse
it
me,
is
sir.
clear.
I think in the traditional design we have n number of DNS servers, but in the modern design we have only one master DNS. This is what I
And
can.
one F5. Right. What is L load balancer doing here?
Is doing load balancing for the DNS request, DNS query.
Good. One component is missing. What is that? Very important. One component is missing. What is that? In the traditional and modern.
The big IP.
I hope two components are missing. Or maybe more. What are those?
Two component is missing in modern design.
Yes.
One is firewall.
Very good. Firewall is not there. Load balancer.
Load balancer.
Here there are multiple of the DNS
Multiple.
server. Those multiple of DNS server are not there. Except them,
Big
we
IP.
have only
Big IP.
big IP DNS. See, are you getting what I am trying to tell? You can observe something or no?
Yeah.
Could you please explain? That is better.
You can save.
I will explain, but currently just I am like in the childhood we find out, we spot the difference between two diagrams. Just I am doing the same. That what are the difference between these two figures, these two diagrams.
Okay.
Sir, what is this
yeah.
master DNS? Sir? Master DNS?
That I will explain.
Yeah, I mean, rather why firewall is missing? I'm thinking like firewall is for security. How it will be missed?
Wait. That I will gonna explain. Again, I am telling. Currently, I am just telling you the difference. That these are the difference. Yes or no? You spot this difference?
Yes.
Yeah.
These are the difference. I hope you, all of you, spot this difference. Yes?
Yes.
Okay. Now let me explain further. Okay, I'm rubbing these things and putting on mute to both of you. You can unmute yourself later on. So here I am explaining about traditional versus F5 paradigm shift. This is very important question, very important understanding you should have, that F5 DNS is an ICSA certified firewall. ICSA means International Computer Security Associations. It tests the labs under certified many of the product, like either it is used to protect the computers, used to control the softwares, antivirus, firewalls, cryptographic product, preventions, intrusion prevention systems, and a lot of them. Here, DNS don't require any firewall because it is an ICSA certified firewall. This point very important, clear to everybody? Yes, no? Unmute yourself if you're speaking something.
Can you please repeat once? Please.
Right. So DNS itself is acting as a firewall. That is what I'm saying. No extra firewall required before the DNS. Okay. Now, if you see here, in the traditional, let us say we have a DNS server, and this DNS server is not capable enough to handle the traffic. Only one DNS server is there. Okay. So what we did, we kept as two. That okay, instead of one, let have two. If we need the two, we should have some load balancing mechanism in between them. Further requirement is there, we are putting third. Further requirement is there 4, and it can be n number depending upon the usage. First thing. Okay. That is, we are adding more and more DNS server. For adding more and more DNS server, we have load balancer. And to protect them, we should have firewall. And users are coming from. Okay. Then, who is doing the load balancing? A separate device. Okay. Now, let's come to modern design. F5 paradigm shift. Here, when clients are coming, they are learning to F5. I had an previous DNS in my organization. I am not removing that. Instead, there I am transferring the zone transfer. Okay. I am just transferring the zone on my BIG IP DNS, and my DNS will rezone all the queries. Remember, from the first day, I am explaining about this design. Now, what are the benefit? Benefit is I don't require more than one DNS server. It is capable to handle a lot of queries. How much? First, it can work as a load balancer. It can work as a firewall. So earlier, firewall can be a bottleneck. It can be a bottleneck because you don't, place a dedicated firewall for the DNS. This firewall must be handling all the data center traffic also. So what if this firewall has a lot of users, or it is not capable enough to handle the traffic? Then even DNS traffic will also hamper. It can be a bottleneck. Here, if you see, no extra component is required. Direct DNS after the internet, we can place it. It means very fast. No more bottlenecks. So DNS performance is increased. DNS service is faster. Also, let me tell you.
So do we require LTM here?
No.
For load balancing the DNS queries?
If you remember, in last class I talked about GSLB.
Okay, it will do.
Who was doing that? DNS. Yeah. So we don't require any load balancing system. It is DNS who can do the load balancing, not in your same data center, but globally. Global server load balancing. Who is doing? DNS is doing. So we don't require it at all. Secondly, it hyperscale up to 200% rapid response. Rather than this DNS, it is 200% increasing the response. Here, maybe you can have 75 KB or maybe RPS, we can say. Okay. So 75K RPS can be maximum query response. But in case of BIG IP DNS, it is 200% than a premium DNS server, and 500 multiplication than a simple bind server. Faster than it, 500% faster. So that is why your DNS is providing or taking the lead in the market. Any question in this? Okay, I hope no. Then one more point I would like to add over here. Have you guys heard about DNS 64?
Might be it used for IPv6.
Yes. So let us say if behind the DNS servers there are application servers which are running on IPv4, but your clients are coming over the DNS, maybe not on this diagram. I need to create on this diagram. Okay. And behind this, there is an application server which is running on IPv4, but client is on IPv6. Such kind of design is also possible using your DNS, FIDNS. I hope you guys heard about full proxy in the LTM.
Yeah.
Sorry.
Yes, sir.
Okay.
Big IP act as a full proxy.
Correct.
There is no interaction between the client and the server, direct interaction.
Correct. So here also you can have two individual sessions. So DNS 64, you can configure DNS to handle IPv6 only as a client connection, request to the IPv4 only, server on your network by returning the quad A response, right? We discussed about a record. So it would be giving the quad A decode. Now, there can be multiple design. Like in this design, we are not removing our master DNS. But in some condition, let us say we need to just remove this. Why to keep this? Let the DNS utilize fully. What we can do is, whatever IP running over here, we can put the same IP on the DNS. We can just shut it down. Okay. Transfer all of the stuff from here to here. Hook up the cables and everything. Then at the time of cutover, we just shut down this guy and make this thing up. Now all the clients which were using this IP now will be shifted on the DNS. Getting my point? So by that way, even we can remove this part also. Not required. Only one DNS. Fine. Not one DNS, two DNS for your resident to say, I forget that name, residency. Okay. So for your residency, you can have more than one, but yeah, that would be the design. Okay. Now, there are some terms which will come into the picture when we will do our F5 DNS configuration. So you guys will be watching out these terms sooner or later in our classes, like listener, pool, DNS profiles, monitors, data center. Data center is not bit like the data center in the common term, but here data center need to be configured. Okay. Virtual server, not bit like your LTM, but yeah, here also virtual server will come into the picture. Servers, link, wide IP. So these all terms we need to be aware while configuring our big IP DNS. Let us talk about them one by one. Okay. So GTM intelligent resolution perspective. If we talk about, we have couple of things which will come into the picture, like the terms I was explaining you earlier, listener, wide IP, blah, blah, blah. They will be falling down in these categories. Either they will be a physical aspect, either they will be a logical aspect. And DNS will do the metric collection, like either it is up or down, maybe which is fast or blah, 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 lot of metric calculation, and it will do the load balancing. So this is how your GTM will work. Now let us proceed and see what are the physical aspects, what are the logical aspects, how we can check one of them. Okay. Let's see this diagram. Here in this diagram, if you see, we have maybe two links available to our data center. Okay. So your data center, servers, virtual servers, and links are the physical objects. Let us talk about them one by one. But before going ahead, see this picture, because this picture is talking about like how we will be gonna configure all of these elements in our physical topology. First of all, one has to go in the DNS. Okay. There are a lot of things, GSLB and all of those things. Probably we will be gonna touch maximum of them, but let's move to the GSLB first. Under the GSLB, you can see wide IP, pools, high rules, data centers, servers, links, prober pools, monitor, topology, distributed applications. All of those things are present. Let us say we are going to the data center. Under the data center, you can see there is a data center list. So maybe we need to create a data center list. We can just go and we can just say that, okay, there is a Singapore. So we can just say Singapore. There is maybe Europe. So we can just say for the Europe. Okay. We can just say for the USA. Okay. Whatever naming convention in your organization, probably you can use that naming convention, but we can add such of the data centers in our topology. Any doubts so far?
No, sir.
So if you see this data center here, what is it data center? Data center is nothing but the logical grouping of service or application that are typically located in some physical location. Okay, like Singapore DC or EMEA DC, US DC, Australia DC, or Middle East DC, whatever. So the data center configuration will allow BIG IP DNS system to understand about the location, because when you need to do the high availability, this DNS configuration will be used. So representing a group of service or maybe applications residing in a specific geographic location. Okay. Later on, you will be able to understand there would be some pools where we will be placing them, but it's all right. Let's not give a rush and go ahead. So you can see this, right? If you see this data center, you can see this is physical grouping of the device. So all of resource on your network are associated with that data center. Like here is Los Angeles data center. There are some LTMs behind this. Under this LTM, you have the web servers. You have the New York data center, where also you have the web servers. So big IP data center again, group of service application residing in a specific geographic location. And GTM might send, maybe here is the GTM. Okay, let us see. It might send the request over here or over here. Let us say this is also LTM. Okay, it might send the request over here or over here, depending upon some of the criteria. One is the load balancing mechanism. Second, if this site is down, it will gonna send all the requests on the New York, not on the Los Angeles. So depending upon the fast response also, who is providing the fast response or the closest. So that is how your data center will come into the picture, and your GTM can utilize it very efficiently. So let's talk about the servers. What are the servers? Because servers are also which we can configure in our topology. What is server? Anybody?
Provide services to the client.
Correct. Here, the server is again a physical system on your network. So servers can contain the virtual server that are maybe ultimate destination for the your DNS resolution request. And if you see this diagram properly in this particular figure, you can just find out we can have 3 types of servers. Okay, just see very minutely. When requests are coming from internet, okay, this is your LDNS property. It will sending to the root, to the top level, and eventually to your GTM. So when your request is coming to the GTM, GTM has servers configured. Servers are configured of one of 3 types. One is this, second is this, and third is this line. So if you see the first, it is a big IP system. It means any member of your big IP system product line. Like LTM is a big IP, right? So GTM can manage the servers which are behind the LTM. Second, anybody, what is second? Second is some third party load balancing system. And after this load balancing system, again, we have multiple of the servers. Exact servers are which are behind the LB. But there can be standalone servers also, which are providing the application functionality. So these are third-party host server. These are providing you the resource, which are not using your big IP system, neither some third-party load balancing system, bit like your web server, file server, SQL server, or bit like that. But it is directly, it can be there under the GTM. So later on, you will realize that under the configuration, we can have, under the servers, we can have the LTM. Under the servers, we can have the other LB. And under the system server, we can have the standalone servers. Any doubt in this?
I have one query.
Clear.
No, sir. The LTM, the other LB, these are on the different locations? Are these on different?
Yes, yes, yes. These are on different locations, or maybe on the same location. Doesn't matter. GTM, let us say in the Europe. This is under the Europe. This is under the APAC. This is Australia, under the Australia. It can be. Okay.
Okay.
Yes, Ganesh. What query you have?
No, that is a good query he asked. Yeah, good.
Okay. So no questions? Okay, let me proceed then. There is something named as virtual server. Virtual server, if you guys aware from your LTM days, is the combination of IP and
Put.
right? Here also virtual server is same. But try to understand, for the GTM, we will be having something named as wide IP. Under the wide IP, there would be a pool. And under the pool members would be these virtual servers. With load balancing system, virtual server are often the proxies that are allowing the load balancing server to manage the resource across a multiple of the resource. But under the GTM, the pool members would be your virtual servers. Okay. I would be.
Could you please repeat it?
The
one you said before.
Okay. So what I told, when query will come on the GTM, it will come to something named as wide. Okay. Wide IP will have a pool, and the pool member would be your virtual server.
Pool member is a virtual server. Sir, I have this in LTM.
No, see, don't compare with LTM. You will get confused.
No, just in the virtual server we have pools. The pools we have members, and here in the GTM the members is the virtual server.
Yes.
Okay.
Why? Can anyone tell me why? Just think about it. No rush.
Yeah, I think GTM directly contacting only to the virtual server, not with the members. I mean, not with the pool members.
Web server.
See, if there is an LTM, this may be the scenario, right? When client will come for the application topic. Yes or no? Let us say it is
Yes.
hosting an abc.com. So it will give the response to the abc.com. So there would be an HTTP request, and in contrast with what HTTP response will send, right? But what is the case now? What is the newer case? Newer case is, this is old. Newer case is, now there is a client which is saying what is the IP of abc.com. Eventually it will come to the GTM. GTM has two data centers. Let us say this is DC1. Similarly, there is DC2. So let us say it has DC1, okay, and there is DC2. Now I am just talking about DC1. Under the DC1, there is again an LTM, and under the LTM, we have couple of the servers. So this is LTM, and this is the VIP, right? So DNS should give what to this client to interact with the application? It should give the VIP only. No, you just compare with the first design, where the traffic is coming to the VIP. So DNS will give again the VIP to interact with the application. Is it fine?
Yeah, yes. Clear.
Abdul?
No, sir, I didn't got it. How is the flow actually? The first, the DNS query will come from GTM on the wide IP. What I
Yes.
understood.
Yes. So there is a wide IP configured, right?
On the GTM.
There is something named as wide IP abc.com. Okay. Now there is a pool. Under the pool, this is pool member 1. Under the pool, this is pool member 2. Let us say query went to the pool member 1. Pool member 1 have the IP of this VIP. This is the same VIP if we compare with our previous diagram. Now client will go to this VIP directly. Make sense?
So here in the scenario, the LTM is must. The LTM is in.
LTM?
LTM is must because the virtual IP is
No. See, LTM is not must again. If you remember, I gave you 3 scenarios that you can have the LTM, you can have some third-party load balancer, or you can have direct server. Okay. So let us say there is some third-party load balancer. Let us say there is directly server. How does it matter? Flow would be same. I am telling the complex one where you have LTM. Any doubt? Yes or no?
Sir, here in the GTM,
Mm-hmm.
or the DC.
Sorry?
GTM we will have pool. Pool will be configured. The pool member is the VIP or the DC1 or DC2.
So DC1 means what? DC1 means LTM placed there. LTM means what? The VIP. Okay. If you are not clear, do let me know. Do not hesitate. I will explain again. Otherwise, I will proceed up. But you need to understand.
Let me
you need
tell.
to understand. Wait, just a minute. You need to understand about two things separately. One is the DNS query and response. One is the application query and the response. So when a client is need to go to the application, first it need to go for the DNS. Then it can generate the application. And DNS or the GTM is only there for the DNS queries, not for the application. For application, there should be some LTM, there should be some third-party LTM, there should be some direct server. Ultimately, these are the servers will be gonna response. Now, one by one, you explain me about this flow, and then we will wrap it up over here for this particular slide. You can proceed, Ines.
Okay. So when an application request come to the GTM, it will try for the DNS resolution.
No, no, it will not. It's not an application request. It will be a DNS request over the GTM.
Can I proceed?
Okay. Yeah, Abdul, you can explain.
What I understood is when there is a DNS request query from the client, as then TLD, then it will forward to the GTM, the DNS query. The DNS query is resolved by the GTM, and the application query it will forward to the virtual server.
Right.
Whether that is the
and to which virtual server it will go, that decision will be taken by your GTM.
GTM will take.
Getting this point?
Yeah, because it has the data. You showed us data center 1, 2.
Yes, because it has all the information. And on which basis it will take this decision? On the basis of location. Which is the closest, which is the fastest, what is the business logic we are applying. Getting this point?
Yes, sir.
Perfect. Eunice.
Yeah, fine.
Okay. Perfect.
I think this one need to explain the practical scenario to have more understanding.
We will understand better if you have that. Yes.
So you want again. Okay. See. This is a client. This is a server. Client wanted to open abc.com and this is getting opened. This is what everybody is aware of. But in background, there are a lot of things which happen. What are those? When client wanted to go for abc.com, client need to aware about the IP address. For the IP address, client will go to its, again, all the cache and everything, then LDNS, from the LDNS, the root, the top level domain, maybe second level domain, then authoritative server. Now, I am just eliminating everything else. It is coming to the authoritative server, which is GTM in this case. GTM has the wide IP for abc.com. GTM say that, okay, let me check. GTM has two data centers, data center 1, data center 2. Under this data center, what happened? Now I am just explaining about this data center. This data center have the LTM. Under the LTM, there are 3 or 4 maybe application servers. Okay, there is a VIP. This VIP is the pool member. This VIP is a pool member. So in data center 1, there is nothing but a VIP. Here also, there is nothing but is a VIP. This is the data center 1 VIP. Maybe let us say 1.1.1.1. In the DC2, there is same scenario. Let us say there is 2.2.2.2 VIP. So here it is 1.1.1.1. Here it is 2.2.2. Now, when client come to this particular body, it will give one of the closest IP, whatever, business logic, fastest. It will give the IP 1.1.1. Okay. Now client has the IP. Client will go to 1.1.1. It means it is going to the data center 1. Under the data center 1, there is an LTM. Over the LTM, there is a VIP which has the IP 1.1.1. Again, it has the 4 of the servers. Now LTM will do the load balancing and will give the response from one of the fastest server. And this response will come to the client. These are the series of steps that happens in the background. Any doubt?
Sir, in the GTM, we will create a pool. In that pool, we will configure the VIP. Am I right?
Yes. For now, yes. Probably later on I will modify your thing, but for now, yes.
Okay.
Clear to both of you?
Yes, sir.
Perfect. Perfect.
Yeah, no problem.
Perfect. Let's take a quick break of 10 minutes. Then we will resume the class and we will see further of the slides. Okay.
Okay.
Thank you.